Okay, this is the third problem for week one homework. Um, I'm having a hard time kind of explaining it, so I think I understand what it wants. Um, but I'm just going to read the problem. It says, given a sorted array of n integers that has been rotated an unknown number of times, write code to find an element in the array. You may assume that the array was originally sorted in increasing order. So my understanding is like, here's an original example, an original array, right? It's like perfectly sorted. And then this thing here gets rotated. So 7 bumps back to the beginning and each one of these bumps up, right? And then you can rotate it again. So it keeps the sorted orderness of it, but it's just been rotated basically. And then these are the same things, but they've just been rotated the other direction. When I was messing around with it, I don't think it matters for our purposes which direction it's been rotated. So, so my understanding of this problem is somebody, and it's in order from least to greatest, is that somebody wants to find the third, or the 0th element in the array, or the third element, or whatever in the order that it should be. But the problem is the array is not in the order that it should be. So I'm going to call that an initial target. Like I want to find third element is the initial target. But that's not necessarily where that value should be. So we're going to find that out. So kind of broke this one up into 2 chunks. One is to find the offset. So this example here, there is no offset. Offset is 0. It's perfect. This is offset of 1, offset of 2, offset of 3, so on, right? Plus 1, plus 2, plus 3, right? So first thing we have to do is find the offset. We could try and sort the array and then find the thing. But that also wouldn't necessarily, well, I guess we could do that, but then we'd have to read every element in the array, and it's probably not as efficient as we want it to be. So first we find the offset, and then we can just find the value in the specified order placement where it should be. And we can use that to either find the element or the element before it's been offset, or just the value in the actual element itself. Well, okay, so let's find the offset first. So you know, I could kind of think of this as like 2 functions. So find offset. We're going to toss in the array. Low is going to be initialized to 0. High is going to be initialized to the array length minus 1 when we toss it in from the main function. Offset is initialized to 0. And then what we can do is create a while loop. And we can close in from the outside, so we can compare low and high. And if it's in the proper order, low should be less than high. Otherwise, it's gotten jumbled up, right? Or it's been rotated. So we read both of these, and if these are either equal or if low is greater than high, then we're going to increment offset, and then we're going to go in 1 layer, and then we're going to compare this one. All right. Okay. So we do. That's my cat. So we'll use a while loop. Let's say while low is less than high. Just do a little squiggly there. Then I want to increment offset. I want to increment low because we're going to close in. and I want decrement high. Okay, so that these things mean that we're just going to go in a layer from 6.6 to 7.5 to 1.3. We're going to compare by closing in ranks. Okay, so we go through that, and then all we need to do is to return the offset. And then that part is done after that. That's our find offset function. Then we need to find the final placement of the array that we requested. We requested an element, an index, assuming it had not been rotated, but it actually has been rotated. So we have to find that out. So we, in find a placement, we'll toss in the array. We'll toss in our initial target, which is what the problem asked for, whether find me the third thing or the fourth thing or whatever, and then our offset. And then, sorry, I'll try and keep this in focus. So playing around with the numbers, I figured out that to find the placement, all you have to do is add the offset to your initial target. Well, actually, there's another step too, but you can say if offset plus your initial target ends up being more than or even equal to the length of the array, then you just have to subtract the array length because it's gone back to 0. So we can say something like if placement, we could say if, actually I'll just do it this way. I'm just going to create placement first. I'm going to say placement equals offset plus initial target. Now that's not necessarily final, because if placement is greater than or equal to array dot length, then we're actually going to say placement is now going to become placement minus array dot length. Okay, so if it's greater than or equal, then we have to modify placement. We have to subtract the array length from it. If not, then we just leave placement as placement, and then we can print out placement is placement. There we go. So the way I approach this is I broke it up into two. I mean, you could do it in one function, I guess, because it's just a while loop really here. But it helped me to sort of break it down into two sub problems, basically finding the offset and then just using that offset to figure out where it's supposed to be. Okay, bye.